system of glands which produce hormones for regulation. So, definitely here it says a system of ductless glands that secrete chemicals, which we'll call hormones, into the bloodstream. So the endocrine system is made of a whole bunch of various glands. We'll talk about some of them specifically. But they produce these hormones, these chemicals, and they send them directly into the blood. So they don't send it to specific body tissues. Okay? They just secrete them into the blood, and then the blood carries these hormones throughout our body where they can then have their desired effect. Hormone, the word itself, comes from a word that means to excite. And that's because hormones, when they're released into the blood, they cause something to happen somewhere in the body. So we often will call hormones chemical messengers because they're produced by the glands and they're basically sending a message to some cell or some tissue somewhere else in the body, causing something to happen, causing some kind of change to take place. And so the levels of these hormones changes and varies over time. You know, some vary throughout the day. Some go up and down depending on a person's throughout their lifetime. Some of these hormones are responsible for the reproductive cycle. There's all sorts of various hormones that do different things. But these hormones are generally controlled by what we call a feedback system. A feedback system is a way for these glands to basically turn on and off to regulate and keep conditions constant, to maintain homeostasis. And I think the best way to think about it is to compare like an endocrine gland to a thermostat. So we have a thermostat in this room, and in your house you probably have a thermostat somewhere centrally located. And so what does a thermostat regulate? Carmen?
The temperature?
Yeah, it regulates, this thermostat regulates the temperature of this room. It keeps the temperature of this room at a certain level. Now, does it do that by producing heat? Does heat come out of this thing to warm up the room?
No.
No. So what exactly happens? Let's say the temperature of this thermostat set at 70 degrees. Well, it's monitoring the temperature all the time. Has a thermometer in there to monitor the temperature. When the temperature drops to, let's say, 69 or 68, what does the thermostat do? Nicolette?
Okay, so there are these wires that carry the message to this heating thingy, and that produces heat.
Yeah. So this doesn't directly control the temperature. It directly controls, like Nicolette just said, the heater. There are wires that go from this thermostat through the ceiling probably to the heater in the back. When the thermostat senses the temperature has dropped, basically just sends a message to the heater, some other piece of equipment, to turn on, and it starts producing heat. Eventually, the temperature of the room obviously will rise. When the thermostat senses it's reached 70 degrees, what does it do then?
Turn off.
Sends another message to the heater saying to turn off. We're at the proper temperature, turn off. So again, this is a feedback. It's monitoring, but it itself is not controlling the temperature. It's directing something else to do that. Well, the same is true of hormones in the endocrine system. Okay? Glands of the endocrine system, we use the pancreas, for example, is monitoring the glucose level of the blood. When it senses glucose level has gotten too high or too low, it makes an adjustment. It sends a message. That message is a hormone, which then brings conditions to the proper level, okay? And then it shuts off. We'll talk about that in a minute. So it works on a similar system. Leah? Yep. All right, so these hormones maintain homeostasis or balance, constant conditions, the proper levels of various things in the body. whole bunch of endocrine glands. We're not going to talk about too many of them, but for example, this side we have male, we have the testes are an endocrine gland. Here you see the adrenal glands are shown, the pancreas. On this side we have the thyroid gland in the neck, ovaries in the female, the pituitary gland and the pineal gland in the brain. These are all various endocrine organs, each of which produces different hormones to regulate different aspects of a person's functioning. So to kind of just briefly summarize how the endocrine system works, hormones are these chemical substances, usually they're proteins, that are made by glands and sent directly into the bloodstream so they can circulate all throughout the body. But they only act on certain cells and tissue. Okay, so they don't affect every cell. And when they do affect a certain part of the body, they usually turn on or off some metabolic activity that helps to regulate our body. So we'll talk about some specifics. The pituitary gland is a very important one. It's often called the master gland because it's actually in control of lots of the other endocrine glands. It's kind of like if this thermostat is an endocrine gland, and there's a central area in our school that controls all the thermostats of the school, it'd be like that. Okay, so the pituitary gland is sometimes called the master gland, and it's way up in your brain, just attached to the base of your brain. Okay, it's a tiny little thing. It's only about the size of a pea, but it produces various hormones that are very important to our body functioning. So it produces all these hormones to help other glands. It also produces another hormone that is an important one, and especially for you guys at this time in your life. It's called HGH. And some of you may have heard of HGH. Anybody heard of it? If you follow sports closely, you may have heard of HGH because it's a banned substance in sports. Although people like Andy Pettit got in trouble for using HGH a few years ago. You know what it stands for?
Steroids.
No, it's not quite a steroid. It stands for human growth hormone. Human growth hormone is a hormone that stimulates bones to grow longer, to increase muscle mass, and it's very active probably in most of you right now. Because you're going through a time in life when you're growing, your pituitary gland produces elevated levels of HGH, which causes you to get taller, okay? Causes you to develop. And so at various times throughout your life, you may go through a growth spurt and your pituitary gland may be releasing a lot of HGH. Other times it may not. Eventually you'll reach whatever, 16, 17, 18 years old, and your pituitary gland will drop off in its production of HGH, and you basically stay that height for the rest of your life. Okay. So human growth hormone is responsible for those changes in height and in growth as you get older.
Can a doctor give someone HGH if they have
Yeah, sometimes. Some people, we'll talk about, some people have various disorders in which their body does not produce enough human growth hormone. Sometimes their pituitary gland is not working properly, and that could lead to pituitary dwarfism, which is when, because of a lack of HGH, a person doesn't grow to normal heights. So it's not just being shorter than normal or being sort of on the shorter side of average or even being well below average, but it's because of a hormonal deficiency that's causing that difference in height. And yeah, in that case, if it's diagnosed at a young age, doctors can give people human growth hormone to help them to achieve a more normal height.
What if it's not dwarfism? What if it's just because they're
just shorter?
Unhealthily small?
Well, if they're just genetically smaller, sometimes.
Not even genetically, just I don't know, for whatever reason.
They just are a shorter person?
Really, really
I don't know, they could. I don't know. So, and it depends on when a person is given that growth hormone as to how it would affect them. The other side of that, sort of the opposite, is something you probably would imagine. Some people have a pituitary gland which is overactive and produces excessive amounts of human growth hormone. And that leads to what we call gigantism. This was previously the tallest man alive. He since has died. And now the tallest man alive is, I believe, he's a North Korean. He's about, I think 7'10" is maybe his height, but very tall. Okay, this is a boy who has same sort of disorder, an excess of human growth hormone. He's only 12 years old. Okay, he's already 6'5" and still has a long time to grow. That's his mom next to him. So again, he's almost as tall as the door, and he's only 12 years old.
That's scary.
This is this is the tallest man ever to have been recorded. He was 8 feet 11 inches tall.
What?
He actually, we'll watch a video about him at the end of class today. But he had a tumor in his brain that caused his pituitary gland to produce too much human growth hormone, and it never stopped. His pituitary gland was constantly producing these elevated levels of HGH, even until his 20s. He was 24, I believe, when he passed away, but he was still growing and still getting taller up until that point, when normally a person's done growing at 17 or 18 years old. But he continued growing into his 20s because of this disease. That's his father.
How tall would he have grown?
We don't know. But eventually the problem is that there comes a certain point when your joints, your connective tissue is not able to support, that size. And obviously if you're 8 feet 11, you weigh a lot, there's a lot of mass that your body has to support. Actually, the reason he died is he had to wear ankle braces all the time because his ankles were just not strong enough to support his huge stature. And eventually it caused a wound that got infected, and he died from that wound at a young age. So you'll see him, but yeah, that's his father, who is just of average height. But he's very, very tall.
How did you get into his house and stuff? Because he was so small.
Just had to sort of bend through all. You'll see a video in a minute. You'll see him walking around.
Yao Ming had to get a certain bed for I can't imagine what kind of.
Well, how tall is Yao Ming? Like 7?
He was like
7'6".
7'6".
So man, this is a foot and a half taller than Yao Ming.
There's a player right now playing for San Diego State, and he's 7'4".
Yeah.
Oh really?
7'4", and he was like 7'1" in his junior year.
Yeah, this guy, he couldn't even really play basketball. He wasn't mobile enough, and he couldn't move around. He had even difficulty walking.
Public dunk just standing.
Yao
Alright.
standing, 7'6".
Well, yeah, when you see him, in the video you're gonna see, he's like with his classmates when he was in like 6th grade, but he looks like a tall adult male, but he's really just a kid. He's really just 12 years old. Mentally and developmentally, he's just very, very tall.
Wait.
And you'll see those videos.
Wait, which kid are we gonna watch it on?
The tallest man.
Oh, okay. I didn't know it was
Yeah, Grace?
Doesn't your heart also have to like work hard?
Yeah. You have higher blood pressure to get that blood all the way up there. There's a whole host of things. This is another model. That's how tall he was. This is a strange-looking guy who's about 6 feet tall.
He's 6 foot tall.
Oh my god.
This one really looks smaller.
All right. So let's talk a little bit about the pancreas, another important endocrine organ. It's also a digestive organ, but we're going to talk about it here and in digestive system. But the pancreas has special cells that produce hormone called insulin.
Isn't that a medicine?
Sort of. So insulin is a hormone. It's released by the pancreas, travels in the blood like other hormones, and is responsible for regulating what? Blood sugar, blood glucose levels. Okay, there's actually 2 hormones which control blood sugar, glucagon and insulin. We'll just talk about insulin. Insulin lowers a person's blood sugar. Really what it does, when insulin is released into the blood, it travels to various cells and it basically tells the cells there's too much glucose in the blood. You need to take some in and get it out of the blood and store it inside of the cells. So it sends that message, the cells sort of open up, bring in that glucose, and the level of glucose in the blood drops. It's important for our bodies to have a proper level of glucose. Okay? Blood glucose levels too low are not good. Okay? Because glucose is so important because of what?
Energy.
Energy. Let's just sort of go back for a second. So what part of the cell uses, raise your hand please, uses that glucose? Natalie?
Mitochondria.
The mitochondria. Who can remind me of the formula for the process that happens in the mitochondria? Nate?
Wait, for respiration?
Yep.
Okay, glucose plus carbon dioxide.
Not quite.
Oh, I got it.
Caleb? Glucose?
Plus oxygen.
Yes.
That was.
Hold on. Go ahead. Sidra, let him. Caleb, what else? Glucose plus oxygen.
Plus something.
No, Grace, finish it up. Glucose plus oxygen, we got that.
And it creates the ATP and carbon dioxide.
Yes, water, carbon dioxide, and ATP. So that happens in our cells. So glucose is an important fuel for our cells. If blood glucose levels are too low, a person may become lightheaded, woozy, he may pass out because of that lack of blood sugar. At the same time, an elevated blood sugar level is also dangerous. It's not good for the kidneys, it's not good for the nerves, and so on. So we need to maintain a proper glucose level, and it's our pancreas that helps us to do that. Yeah, Liam? All right. So the way our pancreas works to regulate blood glucose, and you just were at lunch a couple periods ago. Let's say you ate one of those big Rice Krispie treats. So right now in your digestive tract, that marshmallow gunk is all being digested. It's being broken down into sugar, probably glucose, that you're absorbing into your intestine, into your blood. So your glucose level of your blood is starting to rise now. It's probably been rising for a little while. And so what does your pancreas do? Liam? Turns on and starts pumping insulin into your blood.
Is this like the little thing?
Yeah, that's like, this is the top center. So your pancreas turns on and starts pumping insulin into your blood, which tells your cells, all right, too much glucose in the blood, you need to get rid of some of it, take it in. So they do that. What happens to the blood glucose level?
Goes down.
Goes down, drops. Once the pancreas senses that, what does the pancreas do after that?
Supports glucose so that you're not moving out.
It shuts that down, turns off basically, stops producing insulin. Until what?
So you eat something again.
So there's another influx of glucose until there's more glucose going into the blood, and the process would repeat. The opposite also happens. If your blood sugar drops too low, glucagon helps to bring your blood sugar up. But we won't get into those details. It basically works on the opposite of insulin. All right. Any questions about the pancreas or insulin? All right, just a quick video clip.
Many of the body's most basic functions are regulated by the endocrine system, 8 different glands located throughout the body. The endocrine system constantly and quietly does its work, secreting liquid chemical messengers called hormones. These chemicals manage muscle growth and digestion, as well as energy, reproduction, and more. Here in the pancreas, a hormone called insulin is produced and secreted into the blood. When levels of blood glucose or sugar become too high, the pancreas increases production of insulin. Chemicals in the insulin cause body cells to open up, allowing more glucose from the blood to enter cells, stabilizing the amount of glucose in the blood and maintaining adequate energy in the cells. This is just one example of how the endocrine system regulates a number of important body functions.
All right, our last two hormones that we'll talk about, our endocrine glands we'll talk about today, the adrenal gland and the thyroid gland. The adrenal glands, you have two of them. The name itself, ad, means near. Renal means having to do with the kidneys. And these are near the kidneys. They actually sit sort of on top of the kidneys. These two little hats on each kidney, those are the adrenal glands. You know, like a little hat on top of the kidney. And they produce a hormone called adrenaline. Adrenaline is a hormone that's responsible for what we call the fight or flight response. Let's say you go home after school and your brother's home or your sister, and they're hiding in the closet. And as soon as you walk in the door, they come out and yell at you.
How would they be there if it should be actually be in elementary?
So, what if you've ever had that happen? You've been really, really scared. What does your body feel like after that?
It feels like you can't do anything. You just like.
Yeah, your heart is racing. Your stomach feels like weird and kind of queasy. Okay, you like want to punch somebody. Okay, you're sort of all tensed up. Your blood pressure's elevated. These are the effects of adrenaline. Evolutionarily, the purpose of adrenaline is for you walking in a path through the woods and a puma jumps out at you. Okay, it's priming your body to either stay and fight the puma, or I would suggest run away.
Fight the puma.
Fight or flight. And that's the effects of adrenaline.
Usually I get there are no pumas in the
All right.
forest.
Yeah, Blake.
So I was
Right, shh.
I was doing a prank on well, me and my stepsister were trying to do a prank on my dad, but it didn't really work that much. So we put the plastic wrap over our front door, like at my old house, at my old stepmom's house. This is how it is. There's a door here, and there's a bathroom here, and like they didn't come here fast enough, and they saw it, and they ducked under it. Then later, I think they knew we were trying to prank them, so I was going to the bathroom. I was going in, and I opened the door. My dad's standing there with a wolf mask and a bunch of stuff over it, and he screams, and I turn around, and I like fall out the door, and I smack my face against the plastic wrap.
All right, so those are the adrenaline and adrenal glands help get your body ready to deal with some emergency situation. The last one is the thyroid gland. The thyroid gland is in your neck. Okay, it's like a bow tie around your trachea, and it's responsible for producing hormones like thyroxine, which regulates a person's metabolism, how their body utilizes energy. And sometimes people have disorders in which they don't produce enough of these hormones, okay? And they don't use energy very well. They have a tendency to gain weight, even if they're not eating a lot. And it's because of the effects of this low hormone levels. At the opposite end, a person can have hyperthyroidism, where their thyroid gland is producing excess of these hormones, and they may have trouble keeping weight on. They may be jittery or very excited because their metabolism is kind of sped up. And sometimes a person in that situation there's different medications you can take to lower thyroxine levels, or synthetic thyroxine you can take to increase it, but it's a somewhat common endocrine disorder.
Is ADHD related?
No, it's not sort of different, a more neurological disease than due to hormones. All right. Any questions about any of these so far? We're going to save the gonads for tomorrow. Yes, Julianne?
Yeah, I'm gonna be scored on Tuesday.
because this is underactive, so you're gonna say the gonads, or that's overactive.